Hello students, hope everyone is fine and doing well. So we are moving to miscellaneous exercise of inverse trigonometric chapter. Question number 9 to 12 we'll try to solve. Then other questions you can try. These are all MCQ questions. So let me take question number 9. Tan inverse root x equals to 1 by 2 cos inverse 1 minus x upon 1 plus x, where x belongs to 0 to 1. We have to prove LHS equals to RHS. So to prove this, we use the formula 2 tan inverse x equals to cos inverse 1 minus x square upon 1 plus x square. So let me insert the question or type the question. What is the question? Tan inverse root x. So tan inverse root x, this is a given, equals to, now I have to prove something. Now here if you look at into the formula, this is 2 tan inverse x equals to this one. If I want only tan inverse x, what will happen? This 2 will go to the right hand side as 1 by 2 multiplication. So this will be written as 1 by 2. What is the formula? Cos inverse 1 minus x square upon 1 plus x square. So let me put cos inverse. I think this is 1 or 2 steps portion. 1 minus, see here you have x, so x is written as x square. Now you have root x here, so root x can be written as root x whole square. If you want you can put it, otherwise you can write it directly also. Root x whole square. Okay. Upon denominator is 1 plus x square, so it will come 1 plus root x whole square. This is the, just here x is there, so I am writing as x square. Here you have root x, so I have to put root x whole square. Then what you get in the next step? It will become 1 by 2 will remain as is. So 1 upon 2 into cos inverse. If you want to maintain a bracket, you can put cos inverse. Look here, this 1 minus will remain as this 1 minus root x whole square is nothing but x. The denominator it will become 1 plus root x whole square will be x. That's it. That's what you have to prove here. 1 by 2 cos inverse 1 minus x by 1 plus x. So hence you got 1 by 2 cos inverse 1 minus x by 1 plus x. So question number 9 is done. Thanks. Now we'll move to the question number 10. That will be a little bit lengthy question. What is the question is given? Cot inverse. Let me copy the question there. Let me decrease the size of the. Yeah, this is the given question. You can read the question once. Cot inverse 1 minus sin x. Cot inverse under root 1 plus sin x plus under root 1 minus sin x upon under root 1 plus sin x minus under root 1 minus sin x equals to x by 2. I have to prove that the answer is going to be x by 2. So let's start the solution. What I do is there are two ways to solve this. One is you can rationalize the term, both the numerator and denominator, rationalize the denominator, or there is another way to solve it. We can substitute the formulas. So what formulas we can substitute? look here, what you can write here is, in place of 1 you can put sine square x, sine square, let me put x by 2, sine square x by 2 plus cos square x by 2. One you can you write it as sin square x by 2 plus cos square x by 2? Yes, because sin square theta plus cos square theta is going to be 1. So here I'll write this as, in place of 1 I'll put sin square x by 2 plus cos square x by 2. Now you may have doubt why you are taking x by 2. Why can't we take sin square x plus cos square x directly? Because you look here we have sin x term. According to the identity, sin 2x identity, sin 2x is nothing but 2 sin x cos x. 2x is there, that will become sin x cos x. Here we have sin x only. So this will become 2 sin x by 2. Okay, half of the angle it will become cos x by 2. 2 sin x by 2 cos x by 2. Okay, so here this first term, under root 1 plus sin x, I have written as sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. So after writing this, what you can do is plus, now in place of this one, under root 1 minus sin x, that you can write it as it is. Does it come? First thing, let me put the root term here. Control V, and this will become minus sin. Why minus sin? Because you have 1 minus sin x. So in place of 1, again I am putting sin square x by 2 plus cos square x by 2, which is 1 minus sin x, 2 sin x by 2 cos x by 2. Even here also 1 plus sin x. I think let me copy entire thing. Same terms, only one term will be differ. This is going to be minus sign. Because between the two terms you have minus sign here, so that's why I kept minus sign. So everything is replaced. Again here also, if you have doubt, this term is nothing but, in place of 1 plus sin x, I am replacing this one, minus, here also minus, and in place of 1 minus sin x, I am replacing sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2. Then what will happen next step? This cot inverse will remain as it is. Yeah, this cot inverse will remain as it is. Outer bracket will remain as it is. And let me see what happens in the numerator and the denominator. If you look at into this term, this is nothing but a square plus b square plus 2ab. A square plus b square plus 2ab is nothing but a plus b whole square. So under root a plus b whole square is just a plus b. So here a plus b is nothing but sin x by 2 sin x by 2 plus cos x by 2. This is a plus b whole square. Then plus, if you look at into this term, this will come a minus b whole square. A square plus b square minus 2ab. So a minus b whole square under root. So under root and square will get cancelled. So here we will erase a minus b. So here a minus b is nothing but, it will come a minus b. Okay. Now if I comes to the denominator term, this is also again a plus b whole square. A plus b whole square means here also you will get a plus b only, because square and root will get cancelled. Okay. Now here I have to be very careful. Minus, let me put the bracket, because minus sign is there, so minus sign has to be with this minus sign which you have here. I am putting minus sign, and here I am maintaining the bracket because whatever the term you are going to get after simplification of this one, the minus sign has to be multiplied with other term. So this is again the a minus b whole square term. So a minus b whole square, under root is there, so it will be simply a minus b will come. Am I right? So next step, you simplify this one. See what do you get, which is equals to, in the here plus numerator plus cos x by 2 minus cos x by 2 will get cancelled, and the denominator, if I open the bracket here, this will become minus sin x by 2 and plus sin x by 2 will get cancelled. Let me write whatever is left out. Cot inverse, this is left out here, and here fractional will come. In the numerator, cos x by 2 will get cancelled. One is plus sign, one is minus sign, and here you will get 2 sin x by 2. 2 sin x upon 2 will come, and the denominator sin x by 2 will get cancelled if I open the bracket. So here you will get plus cos x by 2, minus into minus is going to be, this is also plus cos x by 2, it will be 2 cos x by 2, 2 cos x upon 2. So what you left out? So here if I do this way, now 2 will get cancelled, then sin x by 2 upon cos x by 2 is going to be tan x by 2, but outside I have a cot inverse term. So eventually you are going to get cot inverse tan x by 2. So but we don't have any formula, right? It has to be cot inverse of cot theta is going to be theta. So if I want theta, cot theta here, it has to be cos x by 2 upon sin x by 2. So what you can do here is, say whether it is a minus b whole square formula or b minus a whole square formula is going to be same. If it is a minus b whole square, I am going to get a square plus b square minus 2ab. So even if it is b minus a whole square, again the formula remains same, a square plus b square minus 2ab. Or a plus b whole square and b plus a whole square, the formulas are going to be same only. So here I make the change here. If I take a as cos and b as sin, so a square plus b square minus 2ab. So here what I can do is, this I can write as cos x by 2 minus sin x by 2 whole square. Okay, cos x by 2 minus sin x by 2 whole square. Even in the denominator also, I am going to replace this one as cos x by 2 minus sin x by 2 whole square. Now by writing this way, even if I expand this one as cos x by 2 minus sin x by 2 whole square, I am going to get same term. Whether you write sin x by 2 minus cos x by 2 or cos x by 2 minus sin x by 2 whole square, the term is going to be same. So that's why I replace this one. So what you get here, it is cos term will be left out, and here sin term will be left out. If you want, you can cross check it. Now 2 will get cancelled. Cos x by 2 upon sin x by 2 is going to be cot x by 2. So cot inverse of cot x by 2 is going to be x by 2. So here you will get cot x upon 2. So cot inverse of cot x by 2 is going to be x upon 2. That's what you have to prove, right? Your final answer is going to be x by 2. So if the question is given as tan inverse, then here you can write sin x by 2 minus cos x by 2. Even here also sin x by 2 minus cos x by 2. So then you will get tan inverse of tan theta, which will be theta. It's totally depending on the given question. Okay. So this is question number 10 explanation. Now you see the question number 11. What do you get here? So you have here, it is question number 11, tan inverse of 1 plus x minus 1 minus x upon under root 1 plus x plus 1 minus x equals to pi by 4 minus half cos inverse x. Okay, so here int is also given, put x equals to cos 2 theta. So let me take the screenshot of this one and we'll try to prove this one. We'll go to next page only. So what do you get here? Hold on. Yeah. So what you can do here is use the given hint and try to solve the question. So first tan inverse is there. So we need trigonometric function. So here first 1 or 2 steps are going to be too big. Then after that your calculations will be easy. So don't get scared of the big term. Now again here in place of 1, I am going to replace sin square x plus cos square theta. Sin square theta plus cos square theta. So let me put here sin square theta, which is going to be sin square there is no theta. Yeah, sin square theta plus it is going to be cos square theta. Cos square theta. So in place of 1 here I replace sin square theta plus cos square theta plus you say x is there now. In place of x I have to replace cos 2 theta. So let me write for one step cos 2 theta. Okay. So as they are given, I replace the term. So then what do you get? It is going to be minus, I should come out of the square, minus, now again this is 1 minus x. Again in place of 1, I'll put sin square theta plus cos square theta, and here I have minus sign. So let me put minus sign here. Okay. Now again denominator is under root 1 plus x, which is same as the numerator, but just one sign is different. So what I do is, and copy numerator as it is. Just in place of minus here, it should be plus. I think rest everything will be same. Again in place of 1 here, I put sin square theta plus cos square theta. In place of x, I'll put cos 2 theta because int is given, x equals to cos 2 theta. Right? Which is equals to, next step what I do is, let me copy the whole step. I have to make minor changes only. In place of cos 2 theta here, if you remember cos 2 theta formulas, there are 4 formulas are there. Out of those, one formula is cos 2 theta is equals to cos square theta minus sin square theta. So in place of cos 2 theta, I am going to replace cos square theta minus sin square theta. So it is going to be cos square theta minus sin square. I don't think so. One line it will come. Sin square theta. Okay, this is one of the identity for if you want to maintain the bracket here, even here also. So what I do is, I think it's going more than one line. Let me decrease the font size. Okay. So here what I did, cos 2 theta formula I replaced with cos square theta minus sin square theta. Okay, so here also what I do is, in place of cos 2 theta, here also I replace cos square theta minus sin square theta. Even in place of cos 2 theta, here also I replace cos square theta minus sin theta. Even here also I do the same. So each and every step I replace with cos 2 theta formula as cos square theta minus sin square theta. Now what we have to do is, see what are the terms are getting cancelled and what are the terms are left out in the numerator as well as in the denominator. So just a minute. Yeah. So here if you see the first term, this much selected part, this is cos sin square theta, and here you have minus sin square theta. So both will get cancelled, sin square theta minus sin square theta. So you left with cos square theta minus cos square theta. So it will be 2 cos square theta under root. So if you want, let me write one step. 2 cos square theta. So it will be cos square under root 2 cos square theta. Am I right? I hope you understood. Minus next term also will come under root. Now what is left in the second term? Here what is left after opening the bracket in this selected region? It will become minus cos square theta plus cos square theta will get cancelled. This is minus of minus will be plus. So it will be 2 sin square theta. It will be 2 sin square theta. 2 cos square theta minus 2 sin square theta. And your denominator is also going to be, I think, same will come except sign changes. So this will be same, and here plus sign will come. If you want, you can check plus sin square theta minus sin square theta will get cancelled here. So it will be 2 cos square theta, and here sin square cos square theta minus cos square theta will get cancelled, and it will be. Now from every term, if I take root 2 common, right? So from every term, if I take root 2 common out, I think it will get cancelled from numerator and denominator. Root 2 will get cancelled. Then what you left out? Under root. Here under root cos square theta, which is nothing but cos theta only. Or root 2 will get cancelled, okay? Cos theta, then you have minus sin theta will be left out. If I come to the denominator, under root cos square theta is again going to be cos theta, then plus next term you left out is sin theta. Okay. So then next step I'm going to solve. I think this steps we used in class 11th standard. From here you should have remembered, I don't know, but we discussed in class 11 how to solve it. So here what you have to divide each and every term with cos theta. So you'll get 1 plus, not equals to 1 plus, here if I divide sin upon cos, which is going to be tan theta, 1 plus tan theta upon, sorry, this has to be minus sign, 1 minus tan theta upon 1 plus, this is going to be tan theta. Okay, so last and final step, second step, which is upon tan inverse. If you remember that one, 1 minus tan theta upon 1 plus tan theta is nothing but it is the formula of tan pi by 4 plus theta. Okay, so I think this multiple times we use this one, tan pi by 4 plus theta. Okay, So tan inverse of tan pi by 4 plus theta is nothing but, which is simply pi by 4 plus theta. So pi by 4 plus theta. Now here what we assume, I taken x equals to cos 2 theta. Let me simplify that one somewhere here. Let me insert the equation. X we assumed is we replace as x equals to cos 2 theta. I think in x equals to cos 2 theta. Now next step I can write this as cos inverse x equals to 2 theta. Can we put cos inverse x equals to 2 theta? That implies, so if you want theta value, what do you get? Theta equals to half cos inverse x. This will be 1 by 2, because if I want here 2 theta value is there. If I want theta, 2 will comes to the LHS sign. So you will get cos inverse theta equals to cos inverse x. So theta value got it as half cos inverse x. So here I can replace finally, which is equals to, in place of theta I'll put cos inverse x, and this pi by 4, that will remain as is here. So pi by 4, in case of theta I'll put half cos inverse x. Why it is half cos inverse x? So here I explain the steps. Theta will be half cos inverse. I think that's what you have to prove. Pi by 4 minus half cos inverse x. So here you have pi by 4. Oh, sorry, this is the formula of tan A minus B formula. Tan A minus tan B upon 1 plus tan A tan B. That was the formula, not plus formula. Okay. So that's it. This is the explanation for question number 11. So what you have done here, most important thing is, one you replace with sin square theta plus cos square theta, and x you replace with cos 2 theta. That is given a hint, x equals to cos 2 theta. Then next step, this cos 2 theta formula I have replaced with cos square theta minus sin square theta. This is one of the formula for cos 2 theta. Then I substitute. Okay. Okay. So we completed this one also. So you try other questions. I don't think so it will be too difficult. So then we'll start the new chapter next class. Thank you. Have a nice day. Be careful.